Welcome back, everybody. Hopefully this one here isn't quite as long as the last 27 and 59-second video, but hopefully this one is shorter and a whole lot more engaging. Maybe if we sing a song or two during the course of our video, that might lighten the mood a little bit. I don't know if I've got it in me today for that, but I'll do my best. Maybe next time we'll try something like that. Okay. All right. So all humor set aside, let's dig into this one here. All right, so we left off with looking at standardizing. Actually, we weren't really standardizing. We were given particular z-scores and asked to find particular proportions of data that were either left or right of a particular z-score. And we used the z-score table to determine that. So what we'll do today, okay, is we're going to go back and refocus ourselves on problems that are similar to what you experienced in reading the Lauren and Kaylee problem about trying to determine particular values, that is finding their z-scores so that we could compare the two classes. So here's an example that one could use to solve a Lauren and Kaylee problem. So we're asked to find the proportion of data, or the probability that a datum lies to the left of 63, where we have a population mean of 65, and we have a variance here of 16, or that is an SD, a standard deviation of 4. So the first thing we need to do is we need to take this distribution and we have to standardize it. So take this and transform it to that, okay? And by doing that, if we translate every single point from the curve to the normal curve or standard curve, we would have that. So let's do this. Let's find the z-score for x equals 63, and we have a diagram below that does depict that. So you can see it here with the area to the left of 63. Now, through the process of standardizing or finding z-scores, right, that same area on the standard normal curve corresponds to so many z-scores, or standard deviations to the left of that value of z. So what we're looking for is this, right? How many standard deviations is 63 from the mean? Well, we can do that quite easily. We can do that by using let's see, click and reveal not working right now. Oh, there it goes. It's responding slowly. So 63 minus the mean. Okay, so this symbol here, x bar, that's the sample mean. Different sources use them interchangeably. I've been using the population mean instead. That's what I've been trying to use as opposed to the sample mean. So 63 minus 65, that means that we have a z-score of minus 0.5, okay, which means half a standard deviation. So that would be half of 1 SD, but left of the mean, left of the population mean. So if we find that, okay, click and reveal again is not that responsive. We'll give it a chance. There we go. Now, intuitively, we could have thought about it this way. How could we have determined the z-score without it? A mean of 65, an SD of 4, a value of 63. Well, I don't know about you, but if a standard deviation, right, if 1 SD is equal to 4, okay, and 63 versus 65, we can see a difference of 2, right? So we're adding on 2. So that 2, how can we arrive at that? Well, that would be 1/2 of a standard deviation. So 1/2 of an SD is 2 units. So that 2 units is what we need in order to get ourselves from 63 to 65. So intuitively, we could figure it out that way as well. Okay, more than one way to get at things. So step 3, okay, so we have standardized, so we're looking at the following. So the proportion that is less than 63 is equivalent to the proportion that are less than minus 0.5 on the standard normal distribution. So according to the z-score table, if you take a look back at your z-score table, let's do that. We're going to look for a minus 0.5, which is here, and to one decimal place, we would have 0.3085. So that means that the probability or the proportion of x being less than 63 is about, well, almost 31%. All right. So moving forward, let's try something else. So that example looked at something being, let me go back for a moment, something being totally to, there's the picture I want, something that is totally to the left of a particular value. Right? As you experienced in the last video, we had a particular problem that looked at an area that falls in between two values. So here we have a new normal distribution that has a population mean of 72 and an SD of 5. So what we'll do is we will standardize that. So we have the same area, okay, the exact same area, okay, that is proportional to the curve we have here, okay, on the standard normal. So we're going to need to find the z-scores that correspond to both z1 and z2, and we'll use that to get the proportion of data in between. So according to our standardizing, and again, instead of listening to me ramble on presenting information on this topic, you might find it really useful to pause, reflect on what's been said, go to your textbook, maybe do that legwork yourself, and then come back and play on and just sort of see, right? Multitask a little bit and see if your thinking aligns with what's here, and go that way. So you should come up with the two z-scores of minus 0.4 and 1.6. So we are standardizing the values of 70 and 80 for a distribution with a mean of 72 and an SD of 5. Okay, now with z-scores, go to the z-score table and we'll look up those standardized values. Okay, or areas on the curve. So at 0.4, we have 0.3466, and at 1.6, we have 0.9452. And again, all of these areas, recall, are to the left. These are to the left of the mean. So, given that situation, that they are to the left, oops, I'm getting ahead of myself here. I want you to recall that what we'll need to do in this case is we're going to take everything that is to the left of 1.6 and subtract away all that is to the left of minus 0.4, okay, which gives us about 60% in the end. So again, going faster, there's a lot of note-taking involved, so again, pause and reflect as you need to. But as I continue on here, let's bring that back to the visual just so we can kind of see and appreciate that. That brings us to, let's see here, where was that? Here. Okay. So really what we're finding, I'll use the standard normal because that's what we're sort of using. So everything that's to the left, if we find all of this area, if our goal is to ultimately just find this, then we would have to subtract away this piece here. Right? So everything that's identified in blue, right? Take away, and I guess that's a really poor choice of color on my part, but take away this area here, right, to the left of Z1, and you'll be left with that area represented by the solid green bar on the graphic. So we'll bring that back into where we were beforehand. Okay, I won't be able to stay on this slide for too long. I'll let you do the pause and reflect, but the solution is about 60%. Now, last but not least, this would not be complete without an application of some form. Okay? So what I'm thinking at this point in time, we've probably maxed the length of this. What I would suggest is that we take time in the classroom and we look at questions like this one, or we look at some of the samples from the text that are going to have us play through the application of the standard normal distribution. Okay, and that'll be a much more rich experience because then we'll be able to flesh out any difficulties. We'll be able to identify some connections. We'll be able to extend maybe some of our thinking through just the richness of some of those questions. Okay, so let's leave it there, and we'll come back at in class when we're together once again.